Welcome to I Must Get Academy. Myself Sandeep Adari. Now my dear students, in this session I would like to cover about the topic hydrology irrigation. Now my dear students, let me tell you one important thing. Whenever you are preparing for the GATE exam, as we are inching towards the GATE exam, if you consider hydrology and irrigation, it will cover around a weightage of 4 to 6 marks in the actual GATE exam. Now my dear students, most of the questions will be from either from fine index or infiltration or either from hydrology, hydrograph or base period, corp period, or these are the major important points which you have to seriously look into the hydrology irrigation topics. So my dear students, let us quickly start. So here we have a question. What is the question here is, a catchment may be idealized as a circle of radius 30 kilometers. There are 5 rain gauge stations shown in the figure. The annual rainfall recorded at these stations in a particular year are given below. So my dear students, they have given the particular areas, okay. Using the Thiessen polygon method, what is the average rainfall? So whenever these kind of questions are asked, let me draw you the question here. Okay, let me draw you the diagram here. Now see, one second students. If I draw the circle here, okay, and if you see, I'm just trying to draw the circle here. And now, if you see the diagram here, okay, we have what, sir? What is the points they have given here? It is G2, G3, G4 and G5. Okay. Paradox. Hello, sir. Hi. Can you hear me, Amma? Okay, very good, very good. So here, see students, I'm just writing G2 here. 1 second, students. So it is G3, it is G4 and we have G5. And we have, I hope everyone is clear, sir. Very good, very good. Here we have is G1. Now my dear students, let me tell you how do you do the problem in Thiessen polygon method. Okay, how do you do the problem in Thiessen polygon method? So whenever there is in Thiessen polygon method, see students, first what you have to do, let me tell you. Connect all these stations, sir. Connect all these stations, okay. If you consider here, connect these stations, okay. Now, have you connected all the stations? Yes. I hope you are clear, students. So you have to connect all the stations in such a way that a polygon is formed. That is called actually the Thiessen polygon method, okay. Now see students, after that we have to see, we have connected the stations now. After that, what is the problem, sir? We have to form a polygon here by drawing the perpendicular bisectors to these lines, okay. So if we draw a perpendicular bisector to these lines, so we can form here one a rectangle or a square, okay, based on the dimensions. Are you following, my dear students, what I am trying to say? In the Thiessen polygon method, what you have to try to do is, you have to connect all the stations here. Connect all the stations, drop a perpendicular bisector here. Once you have dropped the perpendicular bisector there, you should form such that a polygon is formed. Here there should be a polygon formed. Agree, my dear students? Now, if I consider here, see students, if I consider here, this will be the area of one thing, okay. And if you consider here, this will be the area of the other part, okay. Now see students, if you consider the stations G5 or G2 or G3 and A4. Now what will be the areas with respect to that, sir? This will be A5, this will be A4 and this will be A3 and this will be equal to A2. Okay, my dear students. Now whatever the station which comes here, this will be the A1, okay. Now see students, what they have told you, it is a circle, right, kind of thing. If you see, the radius is how much, sir? The radius is 30 kilometer. What is the radius, sir? So the radius here, if you observe here students, if you observe the radius here, this radius is how much, sir? This radius is equal to 30 kilometer. Agree? Now my dear students, when I talk about here, this is a perpendicular bisector here. This is a perpendicular bisector here. So what is a perpendicular bisector? See, if there is a line here, what does a perpendicular bisector do is not only making 90 degrees, it divides into two equal halves. So here if you see, this distance will be equal to 15 meter and this distance will be also equal to 15 meter. Similarly, this will be, if you consider here, this distance is also 15 meter. So my dear students, so how to find out the area, how to draw the diagram itself is the most challenging part here, what I want to tell you. I hope you are clear what I am trying to say. So just by drawing the straight lines, by connecting all the stations, you have to form a polygon, Thiessen polygon. How the Thiessen polygon is formed, sir? By drawing the perpendicular bisector. Now my dear students, here, if you consider here, let me tell you here, if I move on to the next slide, okay. What will be the total area of the circle, sir? Total area of circle is equal to total area of the circle. What is the area of a circle, sir? Pi r square. The area of the circle is nothing but pi r square. This will be equal to pi into 30 square. Because the radius is equal to how much, sir? 30 square. Now, my dear students, this is, we have to find out the A2, A3, A4, A5. Okay. Now, how to find out the area A5. As I told you, when I talk about area A5, it is forming like a square. Because here if the area A5, I have told you what is the length, sir? If you consider length or width, or you can say length or side, side is equal to how much, my dear students? It is equal to 30 kilometer, right? So when I talk about area A5, it is equal to how much, sir? This will be equal to 30 into 30. This will be equal to 900 kilometers square. Now, what is the challenging part here is, how do you find out the remaining areas? But let me tell you, all the other areas are equal. So if you talk about A2, let me tell you, is it A5 or G1, sir? Sorry, this is G1, okay. So please write down this as A1. Because they have, according to the station, we give the areas. According to the station, we give the areas. This is A1. Now, my dear students, we have different areas here. What are the different areas, sir? A2, A3, A4 are equal to A5. So, what are these? These are the remaining areas which you are finding there. So, how to find out the area? Total area of the circle minus, if you see, here how to find out the area of this portion. Are you following, my dear students? How to find out the area of this portion, which I am trying to show you. How to find out the total area of the circle minus the square area, and there are 4 equal halves. So you have to divide by 4. So my dear students, if I talk about this, this will be equal to pi into 30 square minus, what is the area of the square, sir? What is the area of the square? That is equal to 30 into 30 divided by 4. Okay. Now, can anyone tell me what is this area, my dear students? What is this area, sir? If you solve this, what will be the area here, students? This will be equal to 481.86 kilometers square. So, my dear students, we know the areas which is bounded for every station. I hope you are following, students. Now, please respond in the chat box if you have any queries or any questions, so that it would be an interactive session. So, we got the areas of A2, A3, A4 and A5. Now, similarly, my dear students, we got the area of A1. So, if you see here, what is G1, sir? G1 is 910 and the remainings are 930, 925, 895 and 905. So, here if I talk here, now what is the formula for Thiessen polygon method? You can say sigma pi ai upon sigma ai. So, using this, you can find out the average precipitation. Am I correct or wrong? Now, see, students, for A1, the precipitation is 910 and it is multiplied by the area of the square, which is equal to 900. Now, for the areas of A2, A3, A4, A5, all the areas are same. Am I correct or wrong, my dear students? For A3, A4, A2, A3, A4, A5, all the areas are same. So that area is equal to 481.86. And now we have to consider the remaining precipitations here. What are the remaining precipitations, sir? 910, 930, 930, 925, 895 and 905. So here you can write 930, 925, 895 plus 905 divided by total area. So total area means you can directly take, sir, if you add all the areas individually also you can do, like A1 plus, A2 plus, A3 plus, A4 plus, A5. Am I correct or wrong, my dear students? If you do this entire area, what you will get, sir? You will get the area of the circle. Or for your better explanation, means if you are unable to understand that, you can take the total area as pi r square, that is pi into 30 square. Or if you are not comfortable, area of the square is how much, sir? 900 plus 4 into 481.86. Sir, remember this area or this area will also be equal to pi r square, that is pi into 30 square. Both are same. This is the summation of the individual areas. If you take the as a circle as a whole area, this is the one. So if you see here, students, what you will get, sir? What is the answer you are getting on calculation? Can anyone respond in the chat box? Can anyone respond in the chat box, my dear students? If you see here, this area will be equal to 912.56 mm. What, sir? 912.56 mm. I hope you are clear. Now see, students, whenever these questions are asked, I would like to tell you some important points in the Thiessen-Polygon method. Okay, important points in solving any Thiessen-Polygon method. Okay. So when I talk about the points related to the important points in Thiessen, Thiessen-Polygon method, see, my dear students, here what I would like to tell you, sir, here in Thiessen-Polygon method, first join all the stations. What, sir? The first point you have to do is join all the stations. Okay, with what, sir? Join all the stations with what? With straight lines. So this is the point where you have to remember. Now, what you have to do after that, what we have done, sir? Can anyone respond in the chat box? After that, what you have to do is drop a perpendicular bisector. Such that, drop a perpendicular bisector such that what will happen, sir? Such that a polygon is formed. What, sir? Such that a polygon is formed. Drop a perpendicular bisector such that a polygon is formed. I hope you are clear, students. Now, after doing this, what is the next step is you have to find out the average precipitation using the formula sigma is equal to 1 to n PIAI. Okay. And remember, sir, sigma AI. And if they ask you what is weightage factor, they can ask you, Amma. Weightage factor for area means AI upon sigma AI. This we call it as what, sir? What we call this, students? This point we call it as the weightage factor. This point we call it as weightage. Now, my dear students, when I talk about this also, how to form this area is very, very important, sir. How to form this area is very, very important. Why? Because, see, students, there can be a case, see, I am just giving you the another examples also. There can be a case where here, one second, students. See, this can be also a station, sir. Like they can give you station A, station B, station C, station E. How do you do the perpendicular bisector? Now see, students, first they are already joined in straight lines, right? The first point is what, sir? They have already joined in the straight lines. So how do you form the Thiessen polygon method is important. So here what you can do here is, you can draw here a perpendicular bisector such that it cuts these two lines. Similarly, you can draw a perpendicular bisector here. Okay, and after that what we do? We draw a perpendicular bisector following this, and we draw a perpendicular following this. Are you getting me what I am trying to say, sir? So you are trying to draw here, my dear students, the perpendicular bisector of this point, and similarly the perpendicular point of this point, and the perpendicular bisector of this point. So what will be the area, sir? If you take station A, what is the bounded area is this one. For C, what will be the bounded area? This one. For A, this entire area will come into picture. And this entire area will come into picture. And for this will be the area. And remember, my dear students, you should be careful in finding these areas. You should know a basic thing is, what is the area of equilateral triangle. While solving this kind of problem, my dear students, you should have a idea of what, sir? You should have an idea of area of equilateral triangle. So, my dear students, if you talk about the area of the equilateral triangle, it is root 3 by 4 a square. Still you know basic maths, but it is my responsibility to give you some difficult kind of problems how we do in the Thiessen polygon method. I hope everyone is following. If you have any queries, or if you feel that hydrology irrigation you want to learn, then just click on this link and join the session, students. Now, my dear students, what we do at IMS Gate Academy. Let me tell you, my dear students, you have already done all your preparation and you have done already your practicing mode. So it is the time to test yourself. So how do you test yourself, sir? Sir, testing yourself is not only the one thing. First thing is, you should be accustomed to the gate environment. How to accustom to virtual calculator, how to manage your time, how to be time bounded for 3 hours, what kind of realistic questions. If you see in a gate nowadays pattern, we are seeing questions from NAT, MSQ, multiple select question and multiple choice question. So we have to cover this, and with this same replica of the gate environment, if you can practice this, it will boost your confidence. And at the same time, my dear students, if you are facing any mistakes, how these mistakes can be converted into strength. So we at IMS Gate Academy have come up with this test series plus with the same replica of the gate environment. And let me tell you, we are providing the 12 test series. In this, we are providing the multiple select question, multiple choice question, NAT question, and you will be practiced to the gate level kind of environment and gate level of questions. In addition to this, for any successful student, we have heard that the important thing what we have observed is, for any successful student or any toppers, they have noticed that by solving the gate previous year questions, 100% success can be achieved. So if you are just now also preparing for the gate exam, still you have the basics, but still I want to attempt the gate exam this 40-50 days. Definitely if you can solve this gate question booklet and just before 1 month, if you solve the test series, definitely you will have high chances at least to qualify for the gate exam. So what we have done is, we have done about the test series plus, it is a combination of gate question booklet of 33-year questions. Along with that, we are giving you the, we are providing the test series of All India mock test, which we call of quantity of 12. In addition to this, my dear students, if you want to have a proper guidance after the gate exam, which college you have to choose or which branch you have to choose, this kind of, or how to overcome your challenges, we have a My Plan session which is provided by us. In addition to this, whatever the doubts you are facing in test series, or if you are facing in the gate question booklet, we are providing the doubt solving portal where you can post the doubts in the test series or in the gate question booklet, and you can get back to us. So this is all about the test series plus, my dear students. Now, my dear students, if I talk about the next important thing is what we do at IMS Gate Academy. We at IMS Gate Academy offers online gate coaching, offline gate coaching, and also, my dear students, we are also providing the best content related to the online or hybrid model. We are providing the offline gate coaching at where, sir? We are providing at Bangalore, Jayanagar, and also at Malleshwaram, and also we are providing the offline gate coaching at Vijayawada. Now let me tell you, my dear students, what is the procedure for the gate preparation. So my dear students, for every gate preparation, you should be well aware of the material or the content. So regarding the material, we are providing the exercise book, we are providing the we are level 1 questions, level 2, level 3 questions to all the extent. If you are preparing for SSC JEE, it might be level 1, or if you are preparing for AW, level 2, or assistant executive engineers. If you are preparing for GATE and IES prelims, then level 3 will help you. In addition to this, my dear students, we are providing 33 plus years of GATE question booklet. And for the students who are enrolled, there is no need for separate test series plus. We are already providing the test series plus with all the features of all India mock test and GATE environment. In addition to this, we are providing the My Plan sessions of around 12, and for your entire journey of preparation, how you have to prepare and how to overcome your challenges, what should be the GATE journey, or what should be the preparation strategy, or general awareness, what are the challenges you are facing, or after the GATE exam, how you want to apply for the premier institutes, or for based on your GATE score, which college is best for you, or which branch is suitable for you, because we have different specializations. If you consider in civil engineering, we have different specializations like structural engineering, geotechnical, transportation. Similarly, in mechanical, we have thermal, manufacturing, and also design. Similarly, in ECE, we have telecommunication, and also you can say in electrical, we have power systems, or you see VLSI, we have in ESC. So based on your GATE score, that guidance will also given in the post-GATE guidance. So this is all the links are given in the description. You can just click on the link, and you can just, if you have any query related to this, you can click on the description and join the link. Now, my dear students, what we do at IMS. So now I don't want to waste much of your time. So please try to solve this question, students. I'll give you 2 minutes of time. Okay, and see, my dear students, whenever I tell you any GATE question or anything, it is my sincere advice is to you is any question should be learned or taught, or you can say first read the question carefully. After reading the question carefully, try to write the given data, because based on the given data, you can know or you can apply the formula which comes to in your mind. Until unless you put in pen and paper, it is quite tough to get the formula itself. So please write down this. I hope you are going through the question. Okay, my dear students, I have given you enough time. Now see, students, see the question here is, please read the question carefully. A catchment is idealized as what, sir? 25 kilometer into 25 kilometer square. It has 5 rain gauges, 1 at each corner. Agree? Now, my dear students, during a month of the precipitation at these gauges is measured as G1 as 300 mm, G2 285, G3 272, G4 290, and G5 288. What is the average precipitation method using the Thiessen polygon method? So, my dear students, when I talk about this here, first, if I draw the diagram, okay, now see, students, we have here G1, here G2, sorry, G2 here, G3, and G4, and we have at the center G5. This is the question they have given. Now my dear students, if you see the perpendicular bisector at this point, okay, these are the perpendicular, such that a polygon should form, okay. So my dear students, if I ask you here, one second students, if I join these lines, I have to join these lines such that what it is formed, sir? Such that a polygon is formed. Agree? Now, my dear students, if you see what is the length they have given, sir? The length here is given as 25 kilometer. What is the length here they have given, sir? 25 kilometer. So here, what will be the distance from here to here, sir? This will be equal to 25 by 2. Because it is a perpendicular bisector. Similarly, here also it is 25 by 2. And you can say here, students, what is this, sir? G5. G5 is a kind of rhombus, you can say. This area is nothing but a rhombus. Yes or no? So, from A1 to A4, areas are same. If you see these areas, my dear students, if I consider these areas are same, right? So, from A1 to A4, all the areas are same. So, here I can write A1 is equal to, A2 is equal to, A3 is equal to, A4 is equal to, what is the answer, sir? You can say half into base into height, right? For a triangle, that is equal to half into 25 by 2 into 25 by 2. So, this will be equal to 625 by 8. Okay, kilometer square or whatever the units they have given. Okay, sir, they have given the areas in what, sir, length? 25 into 25 kilometers. So, 625 by 8. Now, see students, what is A5? A5 is nothing but the area of rhombus we have to find out. What is A5, sir? A5 is nothing but the area of rhombus we have to find out. How to find out the area of rhombus here, my dear students? Area of rhombus is nothing but what, sir? 25 into half D1 D2. Sir, do you know what is the area of rhombus? The area, most of the people are not aware or not aware, just giving you, it is the product of the diagonals by half. So, this will be equal to 625 by 2. So, my dear students, we have known all the precipitations, we have known all the areas. Now, just you have to plug in these values in the formula. What is the formula, sir? I told you already. What is the formula I told you, my dear students? P average. Average precipitation is equal to what, my dear students? You can say here, average precipitation is equal to sigma I is equal to 1 to n PIAI upon sigma I is equal to 1 to n. Sigma I is equal to 1 to n AI. I hope you are clear. Now, what are the gauges, sir? Let me write you the gauges. 300, 285, 272. Let me write here. 300, 285, 272, because we should write, no? 285, 272. I hope you are following, sir. And we have 290 and 288. Next one we have is 290 and 288 mm. Now, see students, we already know areas are same. Okay, area is how much, sir? 625 by 8. Apart from A5, see, here if you see, we have written for A5, the area is different. Remaining things are same. So, here what we can write, sir? Area will be common. So, if you take 625 divided by 8, this is the common area. For what, sir? For 300 plus 285 plus 272 plus 290. And the area of the fifth one is how much, sir? What is the area of the fifth one? It is 625 by 2 into, what is the precipitation of fifth one, sir? 288 into multiplied by 288. And if you see the total area, remember my dear students, if you see A1, A2, A3, A4 is equal to how much, sir? It is equal to 625 divided by 8. Okay, now if you consider here 4 into 625 by 8 is equal to how much, sir? 625 by 2. This is how much, sir? Summation. Summation of A1 to A4. And A5 is how much, sir? A5 is also 625 by 2. So if you add these two, you will get 625. Or directly you can take the area of the square. That is 25 square, 25 into 25. It is directly taken as 625. Just for an explanation I am trying to say here, sir. So here for this thing, this is divided by 625. Now my dear students, if you have solved the problem, what is the answer you got, sir? What is the answer? Can anyone respond, Amma? Can anyone respond here? This will be equal to 287.375 mm. So please calculate this value. Okay. Now again and again I am telling you, my dear students, whenever you are solving the problem on the Thyssen polygon method, the basic agenda is simple. Join all the stations. Okay. After joining all the stations, drop the perpendicular bisector in such a way that a polygon is formed. After polygon is formed, then you have to apply this formula, and I told you A upon sigma AI is nothing but the weightage factor. I hope you are clear with this. So let us move on to the next question. So this is also one of the beautiful questions, students. So please try to solve this question and try to read the question at least, and I will give you 2 minutes of time. Okay. So please do this, students. I hope you have written that problem. Now see, students, here see, first you have to read the question carefully. This is a missing station concept, sir. Sir, see, in a catchment there are 4 rain gauge stations, PQRS, the normal annual precipitation. Sir, see, students, if you see, they have given normal annual precipitations. Normal annual precipitations we denote with N for easy understanding. We can easily recognize that they are normal annual precipitation. So if I write here normal annual precipitation, okay, normal annual precipitation. When I talk about normal annual precipitation, students, this is what, sir, what we have, they have given. First one, if they have given for N, for NP it is how much, sir? 780. Yes or no, my dear students? Yes or no? For NQ, the normal annual precipitation is how much, sir? 850. Okay. Similarly, for NR, the normal annual precipitation is 920. And for NS, it is equal to 980 mm. Okay. Now, in the year 2013, stations Q and RS are operative. All are operative, sir, but the station P is inoperative. Okay. The precipitation at P for the year has been estimated as, so precipitation we will represent as P. Okay, my dear students, precipitation, what I am trying to say, I represent with P. So, for P it is 860 mm. And Q and R for the year 2013, same year, Q precipitation of PQ is how much, sir? It is equal to 930 mm. And if you see the precipitation of R, it is how much, sir? 1010. Now, what was the observed precipitation at S? They are asking what was the observed precipitation at S. They are asking these values. What, sir? They are asking what was the observed precipitation at S, that is PS. Agree, my dear student? So, see students, if I take here, they are asking for the missing station, right? We have started with P and NP. Now, see student, if I see the formula here, solution, precipitation of P and normal annual precipitation of P is equal to 1 upon m minus 1, okay, where m is the number of stations. What, sir? Where nm is the number of stations. Okay. So, here they can give you precipitation of Q plus normal annual precipitation of Q plus PR, precipitation of R, plus normal annual precipitation of R, plus precipitation of S upon normal annual precipitation of S. So, if you solve this one, here what is M, sir? Here M is taken as 4. Now, in some books, my dear students, this can also be written as formula as 1 by M. There 1 by n means this station will not be included. When station which you are calculated is not included. Here m minus m means the station which is missing also will be included. Okay, sir, we have to keep this in mind, my dear students. Now, see students, precipitation of PP is 860 and this is 780. So, how to solve this problem? 860, I hope you are following, 860 upon 780 is equal to 1 minus 4 minus 3. That is how much stations, sir? 3. Okay. Upon what is Q? Q precipitation is how much, sir? 930 and 850. So, you can write here 930 upon 850. This is Q. Next one what we have, sir? I hope you are following. Next one we have is R. What is R? 920 and 1010. So, you can write here 1010 upon 920. Precipitation of PS we have to find out. PS upon. What is the precipitation of NS, sir? What is the precipitation of NS? NS we have is, NS is 980. Okay. Upon 980. So, if you solve this, can anyone tell me what will be the value, sir? I will give you 1 minute of time. Can anyone tell me what is the value of precipitation of S? If you solve this, you will get a precipitation value as 1093.4 mm. What is the precipitation we will get, sir? The precipitation of S which you have calculated will be equal to how much? 1093.4. Okay. So, please try to write down that, students. Any doubts in this? Sir, see in this question, this is a normal ratio method or we can say missing station. Okay. So, how to find the missing station is using the normal ratio method. You can find out this formula. Okay. Using this formula, you can solve the problem. I hope you are clear. And similarly, my dear students, there is one more concept, how to find out the number of rain gauges. What, sir? Okay. Now my dear students, the number of rain gauges is given by the formula CV upon E whole square. Okay. Now see students, what is CV here? CV is nothing but the coefficient of variation. What is CV, sir? CV is nothing but the coefficient of variation. And E is the percentage allowable error. What is E, sir? E is the percentage allowable error. Agree, my dear students? What is CV here? CV is nothing but the coefficient of variation. E is nothing but the allowable error in what, sir? In percentages. Now, my dear students, they can ask you what is CV. CV is nothing but sigma upon PA into 100. Again, you can ask me what is sigma. Sigma is nothing but the standard deviation. What is sigma, my dear students? Sigma is nothing but the standard deviation. What is standard deviation, sir? It is equal to sigma. I is equal to 1 to n P individual minus P average whole square. If it is less than 30, n minus 1. This is how you find out the standard average upon P is average precipitation. This is what, sir? This is the average precipitation. Okay. So, and you know the what is the allowable error also. So, please write down this, students. So, please write down this. If you have any queries, you can ask me, sir. Okay. Now, how to find out the average precipitation? I hope you are clear now. Average precipitation is nothing but the summation of the precipitations divided by number of stations. This is nothing but the average precipitations. So, please write down this, students. Clear, sir? Okay. Now, my dear students, it is one of the good question only. Please try to read this question, students. I will give you 2 minutes of time. And sir, see, it is not about learning that question only. You have to know in and around of that question. Okay. Sir, see this question. It's a simple question, but you should know this. Okay. Now, see, students. First of all, they are asking ISO, equal temperature, right? So, when they ask you equal temperature, what is this? We'll see. Sir, whenever the term equal comes into picture, whenever the term equal come into picture, you will have ISO. Okay, you will have ISO. Okay, sir? So, if you see equal temperature, what is this? A line joining equal temperature, first of all. When they ask you what is a line joining equal temperature, this is called isotherm. What, sir? Isotherm. Okay, my dear students. Similarly, they are asking what is the line joining equal humidity. A line joining equal humidity is what, sir? Isohum. What is this, students? This is equal to isohum. Now, similarly, they are talking about a line joining equal rainfall depth. This is called iso height. So, according to this question, if you ask me what is the right answer, the right answer is C. But here what I would like to tell you is you should know all the remaining terms. Line joining equal temperature is what, sir? Isotherm. Line joining equal humidity is isohum. Line joining equal rainfall depth is iso height. And line joining equal evaporation is isopluth. So my dear students, it is not only a one question. You should understand, again I am telling you, equal temperature, isotherm, equal rainfall, iso height, equal humidity, it is isohum, and equal evaporation, it is called isopluth. I hope you are clear. Okay. Now please solve this question, students. It is a very good question. Try to solve this question. Okay. I'll give you 2 minutes of time. See, my dear students, whenever you see, read the question very carefully. If you can read the question carefully, you can solve the problem. Okay. Sir, try to read the question there. A 1 hour rainfall of 10 centimeter magnitude at a station has a return period of 50 years. The probability that 1 hour rainfall of magnitude 10 centimeter or more will occur in the 2 of the successive years will be. Okay. So, you have to solve this question, my dear students. Okay. I have given you enough time, students, here. Now, see, students, when they have asked you this kind of question, okay, when they have asked you this kind of question, first of all, the probability of occurrence is given by the formula. The probability of occurrence is given by the formula what, sir? 1 upon 1, what, sir? Probability of occurrence is given as 1 upon return period. 1 upon return period. Okay. So, what is the return period we have? What is the return period we have? Return period is given as 50 years. What is the return period they have given, sir? Return period is given as 50 years. So, here when they talk you here, 1 upon 50 is given by the formula 0.02. So, the probability of occurrence is given as 0.02. Now, see, students, according to the binomial distribution, if there occurs n years, the probability of occurrence R indicates successive years, n is the total number of years. According to the binomial distribution, you know, NCR is equal to P power R into Q power n minus R. Okay, this is the binomial distribution, you know. And remember, my dear students, how to find out NCR also you should know. NCR is nothing but n factorial upon n minus R factorial into r factorial. Okay, in probability also you should know. Now see students, they can ask you here the probability of success, the probability of success in n consecutive years or n consecutive years if they give you, okay, in n success in n years if they ask you, it will be p power n. Okay, direct formula is p power n. So in that formula we have probability is how much, sir? 1 by 50 is how much? 0.02, right? We got the value of probability of success is 0.02. And they are asking for r successive years is nothing but 2 or r or n. So here it will be equal to 0.02 whole square, and this value will be equal to 0.004. So this is the right answer. So I hope, which is the option, sir? You can say the option D. What we can say, sir? Option D is the right answer. So see students, it's not about the, see here we are just applying the formulas of the basics. So the probability of success is nothing but p power n, and we got the value as 0.004. Similarly solve this question, students. Okay, sir, see students, here the question is the probability that a 50-year flood occur may not occur at all in 25 years lifetime of project. Okay, so what is the fear? So first we will find out what, sir? Probability of occurrence. First what we have to find out? The probability of occurrence. What is the probability of occurrence here, students? The probability of occurrence is, if you see here, what is the, see you can write as 1 by 50. It is nothing but 0.02. It is nothing but what, sir? 0.02. Now if you see the probability of not occurring, this probability of occurring we write it as P. Now my dear students, if I ask you probability of not occurring, the probability of not occurring can be written as what, my dear students? It can be written as Q. So Q is equal to what, sir? 1 minus P. Q is equal to what, my dear students? 1 minus P. Here if you see, you can write 1 minus 0.02. Not occurring is how much, sir? 0.98. But this is the one which we have to know. They have asked what, sir? The probability of not occurring over a period of 25 years, that is for 1 year. So if you see the probability of not occurring, the probability of not occurring for 25 years, what, sir? The probability of not occurring for 25 years is given by the formula what, sir? Q power n. So that is equal to Q is how much? 0.98 whole power, n is how much, sir? 0.98 into power 25. So if you solve this, you will get a value of 0.6. And remember, in last year also, students, whenever these kind of questions are given in the GATE exam, whether it is rounded off to 2 decimals means, that means it is a 0.60 or 0.61, whatever the exact. But if they can, you have to see, if they give you in percentage, then it will be 60 percentile. Sir, most of the people will be showing, means in the last minute you think that they have given in decimals and put the answer 0.60, then it will be gone. If they mention in percentage, it should be 60 percentile. I hope you are clear. Please write down that, students. Please write down that. Okay. Now this is a beautiful question, students. So please try to understand this question and let me know. Okay, I'll give you 2 minutes of time. Please try to solve this question, students. Okay, please solve this question, students. First read the question here. I'll give you the timer here. Okay, please solve this question, students. Okay, this is a beautiful question, students. Sir, first read the question, okay? What is the given data there, sir? The hydrograph of a storm of event duration 140 minutes, the infiltration capacity linearly decreases. They are asking what is the value of phi index or infiltration index. Okay, students, I have given you enough time here. See, students, if they ask you the phi index thing, you should understand phi index is nothing but the formula excessive precipitation minus runoff time upon time of excess. This is the formula you should remember, sir. What is this? PE minus R upon TE. Okay. So, my dear students, if you see the phi index line, above we say that it is runoff, below we say that it is infiltration. So, if you see what will be the precipitation, see what they have done, if they ask you what is precipitation of PE, okay, if they ask you what is the excessive precipitation of PE means, they have given that as the increases the rate further down and linearly attains at a value of 4 mm per hour. Okay, sir. So, if it is 4 mm, so what will be the things, sir, if you see the excessive precipitation here, whatever the values which are more than 4, sir, whatever the values which are more than 4, that is 8 plus 15 plus 10, right? The values which are more than 4. Am I correct or wrong, sir? So, into what is the time duration for each one? It is 20 minutes because 20 to 40 it is 20 minutes and like that. So, into 20 by 60. So, if you see here it is the excessive precipitation is around 11 mm. Am I correct, sir? But see, if you do in this way, my dear students, if you do in this way, you will find somewhat difficulty. Okay. What I will do here is, for this diagram, I will assume that phi index is between 4 to 8. It is not a correct, means I am just guessing the phi index is between what, sir? 4 to 8. It's a assumption, or you can say guess. Okay. Or you can say assumption here. I am assuming. Okay. Now see, students. Now if you see what is the overall precipitation, sir? 11 mm. Now we know, see, the infiltration capacity of the start of the event is 17 mm per hour. So here they have given all the different values, sir. Okay. So, but if I assume that, let me tell you 1 second. If I assume the infiltration index is somewhere here, okay. So whatever the 8 value, 15, 10 and 8, if you find the difference, I am assuming this at x, this, some x. So what will be this value, sir? 8 minus x. Means this is 5 value. Actually it is how much, sir? 4 mm. 4 mm they have given, 4 mm per hour. So see students, I can write here. Here I can write that 8 minus 5 plus 15 minus 5 plus, what is the other thing we have? 10 and again 8 plus 10 minus 5 plus 8 minus 5. This whole thing into 20 by 60 should be equal to the runoff, which is equal to 4. Yes or no, sir? Which is equal to the 4. Or you can say, see students, here it is how much, sir? 15, 10, and here it is how much? 8. Suppose if I have taken this C, here how to find the area above 5 index line. Okay, or 5 index line or the dotted line. Sir, here it is a rectangle, right? So you can write it is 15 into 20 by 16. Okay, and see students, you can take directly, this is one other triangle and this is one triangle. So what is this triangle, sir? You see here it is 15, right? You can write here, what is this triangle? From here to here it is 20 minutes. So from 10 to 8. So here it is following from 15 to 10. Sorry, here it is also. Sir, are you following? What is this height, Amma? 15 to 10 is how much? 5. 5 into 20 by 16. So 5 into 20 by 60 plus, what is this height, sir? 10 to, I told you, 10 to 8 it is following. So plus 2 into 20 by 60. Are you following, students? It is 2 into 20 by 60. Next, this is another rectangle. This is how much rectangle, sir? From 10 to 8. So it is, here it is a triangle, sir. So half into 2. See, this is 5 into 20 by 60. This is half into base into height. So 10 into 8, 2, and this is 20 by 16. Next we have rectangle is how much, sir? Half into 2 into, sorry. Next we have rectangle is 2 into 20 by 60 plus, are you following, my dear students? Plus, now this triangle, whatever this triangle, sir, from here to here it is 40 by 60. And if you see here it is 40 by 60, and what is this height, sir? 8 to 4. So half into 4 into, because it is falling from 8 to 4, right? So half into 4 into 40 by 60. So see students, if you consider here, if I take 20 by 60 common there, okay, if I take 20 by 60 common there, this will be equal to 5, and half cancel 1, and here it is 2, and here 20 by 16 is 4. Am I correct, sir? So see, 5 plus 1 plus 2 plus 4, how much, sir? 6, 8, 12. So this is equal to 4 mm. Am I correct, sir? Yes or no? So what I have done, above we call it as what, sir? Runoff. Below the 5 index we call it as what? Above it is runoff, and below we call it as what, sir? Infiltration. Using the 5 index, we have find out the area of the runoff. So we got here, runoff is equal to how much, sir? Above the dotted line, it is equal to 4 mm. So how do you get the 4 mm is, it is just finding the areas, sir. Now, the same thing should be equal to runoff how much, sir? Now the same thing should be equal to runoff how much? It is equal to 4. I hope you are following. I am assuming that 5 index lies between 4 and 5. Sir, please listen carefully here, students. Sir, this area, whatever the area which I have founded here, okay, whatever the area, let me tell you. Sir, see, whatever this first area is how much, sir? 15 minus 10 is 5, and into 20 by 60. This is the one, sir. This is the first one. And we have next one, this is triangle. Triangle is how much, sir? 20 by 60. And it is falling from 10 to 8. So half into 20 by 60 into 2. So that's what triangle we have done. Next we have third one is this one, rectangle. So 10 minus 8, we can write 10 minus 8 into 20 by 60. That's what I have done, 2 into 20 by 60. Next what I have done, sir, from here to here, This is an complete triangle. The complete triangle is falling from where? 8 to 4. So this distance is how much? 4. And what is the distance from here to here? 60 to 100 minutes. So 40 by 60. Again you can ask me, sir, why you are doing with 60? Sir, these are what, sir? These are time in minutes. But we want in hours. So because the values are given in mm per hour. Because the values are given in mm per hour. Are you following, my dear students? So above the 5 index line, what I want to tell you is, above the 5 index line, we consider it as runoff. Below the 5 index line, I will take it as infiltration. That is the concept, okay? Now, what I have done, I have assumed that 5 index is between 4 and 8, and I have assumed these values, and this should be equal to the runoff, which should be equal to 4. Am I correct or wrong, my dear students? Very good, very good. So, after solving this, you will get a value of how much, sir? 8 plus 15, 23, 33. 41 minus 45 is equal to 20 by 16 is 1, that is 12. So if you do here, 45 is equal to 29 mm per hour. So you can write 5 is equal to 29 by 4. So this will be equal to 7.25 mm per hour. So this value will be equal to how much, sir? 7.25 mm per hour. So let me tell you, my dear students, whenever you are solving these lines, you should always remember above 5 index, you will get the area, above 5 index area will get runoff, and below 5 index, if I talk about below 5 index, you will get below 5 index. These are the important key points, sir, in this problem, is we will get the infiltration. But if you add infiltration and runoff, you will get the total precipitation. Okay, sir, the total area of the diagram, not above 5 index or anything. The total area should be equal to what, sir? If you find the total area, then you will get the answer as precipitation. Okay. So, my dear students, I hope you are clear with this problem. So, please solve this problem. Okay. Okay, this is another important question, sir. This is a very interesting question, and this is a kind of question where you can have to apply your mathematical skills also. So, I will be very happy if anyone solve this question. And I will give you 2 minutes of time. Please solve this question. Sir, please read the question carefully, students. Okay, I have given you good time, students. Now see, the question here is a 12-hour storm occurs over a catchment and results in a direct runoff of how much, sir? 100 mm. The time distribution of the rainfall intensity is shown in the figure. What is the phi index of the storm? So when I talk here, when they talk here, they are asking what is the phi index. So my dear students, when you talk about the phi index, usually we will calculate W index. Whatever the values which are more than W index will be taken into consideration, and we will solve the problem using phi index is equal to excess precipitation upon time of excess. This is the formula. But if you follow this method, no, it would be somewhat tricky. So better follow the method which I am going to tell in the previous problem also. Now see students, the area of the graph means what is the area of graph, sir? For suppose area means what? X-axis into y-axis. Leave the shape, sir. It is intensity into time. If you consider the intensity into time, what you will get? You will get total precipitation. So always remember, my dear students, whenever you are solving the area of the graph, what you will get, sir? Area of the total precipitation. So it is a kind of trapezoid. See students, if you have a trapezoid here, if I consider this as side A, this as side B, and if I have height, what is the area of the trapezoid, sir? The area of the trapezoid is nothing but, the area of trapezoid is what, my dear students? The area of the trapezoid is nothing but half h into A plus B. What is the area of trapezoid, sir? Half h into A plus B. Am I correct or wrong? So here, what is the length from here to here, sir? It is 12. So the distance from here to here is what? 12. And here the distance from here to here is how much, sir? The distance from here to here, it is 4 and 6. So this is equal to 2. And what is the height, sir? That is intensity. That is 20. So here you can say this is 20. So if you get the area, it is equal to half into 20 into 12 plus 2. Am I correct or wrong, my dear students? Am I correct or wrong? So this value will be equal to 140 mm. Very good, very good. So when I considered 140 mm here, this 140 mm is nothing but what, sir? This 140 mm is nothing but total precipitation. What is this 140 mm we have? This 140 mm is nothing but the total precipitation. But in the problem, they have given the runoff value as 100. What, sir? They have in the problem, they have given runoff as how much? 100 mm. So my dear students, now you know the precipitation and you know the runoff. How do you calculate infiltration? Let me tell you. Infiltration, runoff plus infiltration should be equal to precipitation. So infiltration is equal to total precipitation minus runoff. So this value should be equal to 40 mm. What is this value, sir? 40 mm. Agree, my dear students? Yes or no? Now see students, now I have to assume the phi index. This is one of the important things where you have to understand. One second, students. One minute. I am just trying to draw the diagram, sir. Okay, they have given in the diagram as this value. So this value is how much, sir? If you see, this value is 20. Okay. And this value is 4 to 6, I think. Yes, sir. This is 4. This is 6, right? Yes or no? And here what is the value, sir, we have? That is 12, right? Okay. Now this is the diagram. Now my dear students, see, this is the important mathematical kind of stuff, sir. Okay. Now my dear students, I have assumed that this is my phi index. And what is the area below? Area below phi index will be equal to, students, just now I told you, area below phi index line will be equal to how much? Area above is what, sir? Runoff. Area below phi index is what? Area below phi index is nothing but what, my dear students? This is equal to infiltration. This is equal to what, sir? Infiltration. Okay, now see, students, I don't know what is this distance, right? I don't know what is this distance. I don't know what is this distance. Okay, so here what I will do is, I will assume this distance as y1 and I will assume this distance as y2. Okay, what will be the distance from here to here, sir? What will be the distance from here to here? This total distance is 12. So this distance will be equal to 12 minus of y1 plus y2. Okay. Now this phi index I will assume as x, this vertical distance. Now from similar triangle concept, x by y1 is equal to 20 by 4. Yes or no? Because see, this distance is 20, the distance from here to here is 4. So what will be the y1 value, sir? Y1 value will be equal to x by 5 by similarity. Agree or not, sir? Now see, students, similarly, x by y2 is equal to 20 divided by, what is the value from here to here, sir? What is the value from here to here? From here to here it is 6. So from the other distance also it will be equal to how much, sir? 6. So y2 is equal to how much, sir? Y2 is equal to how much? 2 3s, 3 by 10x. Huh? Yes or no? Please write down here. What is y1, y2, sir? Y2 is equal to 3 by 10x. Agree, sir? Now we have to find out the area. Now see, students, if I see here, we got x is equal to how much, sir? Y1 is equal to x by 5. Y1 is equal to x by 5. What is y2, sir? Y2 is equal to how much? 3 by 10x, I think. 3 by 10x, okay. Now see, students, what will be the area we have to find out? First we have to find out the area of this. So A1 is equal to how much, sir? Half into x into y1. Y1 is how much? X by 5. Yes or no? Similarly, what is the A2? What is the area? Height is x. This is a rectangle. So x into, what is the length, sir? 12 minus y1 plus y2. What is y1? X by 5 plus y2 is 3 by 10x. Okay. I hope you are following, students. What is A3? Half into x into 3 by 10x. Now see, students, the areas, if you add all these things, that should be equal to how much, sir? That should be equal to the infiltration, because the area below phi index is infiltration. So we can try it. First one, A1 is equal to how much, sir? 0.1 x square. If you solve this, you will get 0.1 x square. Yes or no? X square by 10, 0.1. So here plus x into 12 minus plus x into 12 minus, what is x by 5, sir? It is 0.2. What is 3 by 10? This will be equal to, what is this value? This will be x by 5, 0.2x plus, you can write here, 0.2x plus 0.3x, okay, plus this is how much, sir? 0.15 or 1.5x square, I think. Yeah, 0.15x square. This area should be equal to how much, sir? 40 mm. Now see students, these all things forms a what, sir? If you do this all forms a quadratic equation. What, sir? It forms a quadratic equation. I hope you are following, students. This entire thing will form a quadratic equation. Once it forms a quadratic equation, what are the values of x and you will get two roots, sir. Can you tell me what is the answer you got? You will get two roots. Can you please solve that? What is the x values you got? So if you see here, you will get the x value as 3.6 and x value you will get as some 44.37. Sir, anyhow, this won't be into picture. Why? Because your x value cannot be more than 20 itself. Okay, because the height itself is 20. So the answer here is x is equal to 3.6. Sir, again and again I am telling you, see, whenever you find the area, total area, you will get what, sir? You will get the precipitation. Whenever you find the total area, you get the precipitation. Okay, and let me tell you, area below 5 index, what, sir? Area below 5 index, you will get infiltration. Area below 5 index, you will get what, sir? Infiltration. And area above 5 index, area above 5 index, you will get runoff. And if you know the areas geometry formulas, these problems can be solved if you know these three logics. Okay. Now this is a very good question, sir. I'll give you 2 minutes of time. Try to solve this question. Amma. See, try to understand the given data, what is given over there. In a Horton's equation fitted into the infiltration data for a soil, the infiltration capacity is 10 mm per hour, final infiltration capacity is 5 mm per hour, exponential decay is 0.5 per hour. Assume the infiltration takes place at capacity rates. The total infiltration depth from a uniform storm of 12-hour duration is. Okay. Now see students, whenever these kind of equations are given, first you should know what is Horton's equation here. Sir, Horton's equation is given by the formula Fc plus F naught minus F of C e power minus kT. Infiltration at a time t is given as what, sir? Infiltration at a time t. Why? Because, see students, if you see the graph also, okay, the infiltration will start at initially at this point. Finally it decays. Decays means it decreases. And it will become the final constant rate as Fc. Initially it is what, sir? F naught. If you want to find the infiltration at a time t, suppose at a time t, and this is the infiltration. If you want to find the infiltration at a time t, F of t is equal to what, sir? F of C, this is final, plus it or final or constant infiltration rate, they will tell, into e power minus kT. Okay. Okay, see students, what is k here, sir? If you see what is k here is, k is nothing but the decay constant. What is k, sir? Decay constant. Now, my dear students, here what is Fc, sir? Fc is 5, initial is 10, and total duration is 12 hours. Decaying constant is 0.5 per hour. Sir, see, Fc is equal to 5, sir. 5 mm per hour intensity. And F naught is how much, sir? 10 mm per hour. And K is equal to how much? K is equal to 0.5 per hour. What is the value of K? 0.5 per hour. Now, my dear students, first form the equation. Are you following, students? First form the equation. What is the infiltration at a time t? So, if I talk, what is the infiltration at a time t, sir? This is equal to 5 plus 10 minus 5 into e power minus k. K is how much, sir? 0.5. So, e power minus 0.5 into t. So, my dear students, if you talk about the infiltration at a time t, this will be equal to 5 plus 5 into e power minus 0.5 into t. Infiltration at a time t is given as how much, sir? 5 plus 5 into e power minus 0.5 into t. Clear, sir? Now, see students, they are asking the total infiltration at for 12 hours. So, you can write here 0 to 12 f of t dt. So, my dear students, if you solve here, the infiltration is 0 to 12. What is the value, sir? 5 plus 5 into e power minus 0.5 t into dt, right? Now, if you do the integration, this will become as 5t plus 5 into e power minus 0.5 t upon this will be equal to minus 0.5. Limits are 12 to 0. Now, see students, if you see individually, 5 into 12 is how much, sir? 60 minus 0 plus see minus 10 into this minus 0.5 into 5 is how much, sir? Minus 0.05 is minus 10 into e power minus 0.5 into 12. Next, minus of minus plus 10. Okay. Now, see students, this will be a very minute value because anyhow e power minus 6 is a very small value, sir. You can neglect, or if you want the exact answer, you will get the exact answer as 69.975. So, this value is somewhere around 0.025 mm. Okay. If you neglect this you approximately you can take it as 70 mm. Okay. I hope you are clear. So, what is the key takeaway from this problem is the infiltration at a time t is given by the formula Fc plus F naught minus Fc into e power minus kT. So this formula should be always remembered by you. And let me tell you, my dear students, here when I talk about K, okay, K is nothing but the decaying constant. You want over a period of time, then just 0 to t f of t dt. Then what, sir? 0 to t f of t dt. If you do this, you will get the solution. Please solve that. Please write down that, students. I hope you have written this, students. Okay. Now this is another beautiful question, sir. Try to read this question. I'll give you more time if you want also. So how to solve this problem? Try to solve this question. Okay. Please try to solve that question, students. See, students, you have to understand there what is the hydrograph given in the figure. If the rainfall event has a direct runoff of 1.6 centimeters, the phi index of this event in mm per hour. They have given you already, I have told you how to calculate the precipitation, how to calculate all those values. See, students, here I have given the hydrograph. What is the hydrograph, sir? It is a graph drawn between intensity and this one. Okay, now see. Sir, let me tell you here. I'll tell you how to calculate the area here. Sir, first of all, this is the area where you have to calculate, sir. All these areas. So, my dear students, what is the intensity, sir? There we have 12 plus 4.5 plus 15 plus 14 plus 4 plus 7.5 plus 3. And what is the interval of each one? It is 0.5 r, because anyhow it is mm per hour, or you can write into 0.5. Yes or no? Sir, this is mm, please remember. 12 plus 4.5 is how much, sir? 16.5, 15, 31.5, 31.5 plus 14, 45.5, 49.5, 57, 60. So 60 into 0.5 is how much, sir? This will be equal to 30 mm. What will be the total precipitation here? The total precipitation is 30 mm. Okay. Here if you see students, if you have observed here, what is the total precipitation we have? What is the total precipitation we have, sir? What is the total precipitation we have? The total precipitation we have is how much? 12 plus 4.5 plus 15 plus 14 plus 4 plus 7.5 plus 3 into 0.5 is equal to how much, sir? 30 mm. Am I correct or wrong, students? Now they have given in the problem itself, runoff is equal to how much, sir? Runoff is equal to 1.6 centimeters which is a given data. Which is a given data. Am I clear or not? So usually if you convert this into mm, this will be equal to how much, sir? 16 mm. What, sir? This will be equal to 16 mm. Am I clear, students? So here, first let me find out what is W index. What is W index? So W index is nothing but precipitation upon R upon time. So precipitation, how much you got, sir, in mm? This is 30 mm. Runoff is how much? 16. Upon time, if you see the total time, it started from 0 and in the graph it was showing is how much, sir? 3.5. So 30 minus 16 divided by 3.5. So this is equal to 14 divided by 3.5. So this value will be equal to how much, sir? 4 mm per hour. This value will be equal to how much, sir? 4 mm per hour. So W index is how much, my dear students? It is 4 mm per hour. Agree? So you know now how to calculate the phi index. Sir, please understand, I have been telling you in the different methodology. So in the phi index, what is the formula I have told you, sir? It is defined as the formula of precipitation minus runoff upon time of excess. Now in the precipitation PE, you have to consider the values which are more than W index only. You have to consider the values which are more than W index only. So my dear students, if I consider here, what are the values which are more than 4, which are less than 4, or we have to include the values which are more than 4 only, or you can write here what, students? Or you can exclude here write what values which are greater than W index only. So or you can exclude the values which are less than 4. So 4 can be this 4 and this 3 will be excluded. Remaining all are more than 4 only. Yes or no? So here if you see here, the total precipitation is how much, sir? 30 mm. In that, what are the values which are less than 4? That will be excluded. That means you are taking the values which are more than 4 only, no? So here it is. One is how much, sir? 4 plus. One is 4 and other one is 3.5, I think. 4 and 3, right? 4 plus 3 into 0.5. So here I am trying to find out excess precipitation which are more than W index. This value will be equal to how much, sir? 26.5 mm. What is this value, students? PE will be equal to how much, sir? 26.5 mm. Am I clear, my dear students? Now you know already runoff. What is the runoff, sir? 16 centimeter, or sorry, 16 mm. Okay. Now again, time of excess. How many intervals we are removing? One interval here. So time of excess, total time is how much, sir? 3.5 minus 0.5 plus 0.5, because there are two intervals which you have to remove. Are you clear, students? So here the time of excess is equal to how much, sir? 2.5. So now do you know what is PE, students? Now PE, you have to just plug in that values. PE is how much? 26.5 minus what is the runoff, sir? Runoff is nothing but 16 divided by what is the time of excess there? We have time of excess is 2.5. So we have 10.5 divided by 2.5, that is equal to 4.2 mm per hour. How much, sir? This is equal to 4.2 mm per hour. I hope you are clear. So this is another way of explaining the problem related to the infiltration. So first what I have done, sir, the key takeaways from this problem is we will calculate first the W index. Now in the precipitation of excess, whatever the values which are more than W index will be considered. After that we have the runoff value, and in time of excess those values which are less we have to exclude that values. So we have excluded, there are two values, one is 4 and 3. So I have excluded 0.5 hour and 0.5 hour, and you got the time of excess. Now you have to just plug in that values into the formula and you get a value of 4.2 mm per hour. I hope this solution is clear for you. Okay. Now this is another beautiful question, students. I'll give you 2 minutes of time. Please solve this question, sir. Sir, in this, try to understand the question, Amma, first of all. Okay, try to understand the question in this, first of all. Okay, I have given you enough time. Sir, see. Here, the first, I'll read the question for you students. A canal supplies water to an area growing in over 100 hectares. So, my dear students, what is the area, sir? Area is equal to how much? 100 hectares. What is the area, sir? Area is nothing but 100 hectares. Okay. Now, the duration between the first and the last crop is how much, sir? 120 days. The duration between the first and last crop is, you can say, duration is 120 days. I am just trying to write the given data here. Okay. Next, the total depth of water required by the crop is how much, sir? Total depth of water required by the crop is 35 centimeter. Agree, students? Very good. Now, the most intensive watering is done between 30 days and requires a total depth of how much, sir? So, for first 30 days, what is the required depth of water? It is 12 centimeters. Now, obviously, what is the total duration, students? 120 days. So, what will be the remaining days, sir? Remaining days will be 90 days, right? The remaining days will be how much, sir? 90 days. So, for remaining 90 days, what will be the duration, sir? So, here you have 12 centimeter. So, 35 minus 12, then it will be equal to 23 centimeters. Yes or no? Here you have 12 centimeters, 35 minus 12 is 23. Assuming a precipitation to be negligible and neglect the losses, what will be the minimum discharge? What, sir? They are asking what is the minimum discharge. This is a very good question, sir. What is the minimum discharge? So, let me do in a two ways, Amma. First case, this case I will take it as A and this case I will take it as B. Okay, sir? Now, see, students. So, to find out this, first of all, I should know this formula. Duty is equal to 8.64 base period upon delta. This is a very, very important question, students. Okay, why this 8.64 came is, usually in a day we have 86,400 seconds and we divide, duty is always expressed in hectare. So, 1 hectare is 10 power 4 meter square. So, if we divide that, that value we will get as 8.64. Now, let me tell you, duty units are hectare per cubic. Whenever you are using this formula, this is standard, Amma. Hectare per cubic or hectare per meter cube. Cubic. Next, base period. This is D. Base period is B, which is always in days. Okay, sir. Delta, depth or runoff depth or whatever, depth of water or whatever, which should be always in meters. Sir, these units, they might give you in any units, either any other units, but you have to substitute the answers in this way only. Okay. Now, see, students, in the first case, the base period is given as how much? In the first case, the base period is given as 12 days. Okay. So, days correct. But they have given depth, that is delta. They have given as 12 centimeter. But this should be converted into how much, sir? meter. So 0.12 meter. Yes or no? Now see students. Now you should know base period for first 12 days, not 12 days sir, first 30 days, sorry. 30 days. Now what will be the duty sir? Duty is equal to 8.64 into 30 days divided by 0.12. Can anyone tell me what is the answer you got sir? What is the answer you got? You will get a value of 2160 hectare per cubic. But what they have asked sir? What they are asking? What they are asking in the problem? They are asking the discharge. So discharge will be equal to always discharge is equal to area upon duty. Discharge is equal to what sir? Area upon duty. So what is area? Area is 100 hectares upon duty is how much sir? What is duty? Duty is nothing but 2160. Area is given as 100 hectares sir. Yes. And duty is 100 hectare per cubic. So 100 divided by 1 divided by 21.60. If you see 1 divided by 21.60, you will get 0.046 meter cube per second. Sir, this is for case 1, right? Yes or no, my dear students? Yes or no? Very good. Now see students, for case 2 or case B or case 2, the total duration is 120. So 120 minus 30, duration is 90 days and delta is 23 centimeters. I hope you are following students. Okay. Delta is equal to how much sir? 23 centimeters, which is equal to 0.23 meter. Now see student here, duty is equal to 8.64 base period upon delta. Duty is equal to what sir? 8.64 base period upon delta. So here duty, if you find out, what is the base period they have given sir? What is the base period they have given students? They have given as 90 days. 8.6 upon depth is how much sir? What is the depth here? We have is 0.23. So what is the answer you got sir? What is the discharge? Anyone can tell me? You will get duty as 3380.87 hectare per cubic. Again, now also what I have to find out sir? Discharge. So here also, my dear students, when I talk about discharge, discharge is equal to what sir? Discharge is equal to area upon duty. What is discharge? Discharge is nothing but area upon duty. So here what is area sir? Here area is nothing but 100 hectares. Duty is nothing but 3380.87. So when I do this, 100 divided by 3380.87. What will be the discharge sir? Discharge will be equal to, if you solve this, 0.0293. How much sir? So there is a small twist in this problem. Sir, see. Sir, this is something like supply. What they have asked in the problem, what is the minimum discharge, right? So people have this tendency to write we have calculated in both the cases and whichever value will be the minimum, that will be the answer they think. Are you following what I am trying to say, students? People have this tendency that as we are trying to solve the problem, they have given minimum discharge. So people think that whatever the minimum value you have, that will be the answer. But let me tell you, this is a kind of supply. So when in supply, if they ask you minimum discharge, you have to take the larger value. So the final answer, if you say here the maximum of 2 will be the minimum discharge. This point is important, sir. The maximum of 2 will be the minimum discharge. So I hope you are clear in this problem. Please try to write down this, students. If you have any queries related to this, as I told you, it is a supply, student. So that is the reason. Okay, this is the second part which you have to write. Okay. Now, this is another important question, sir. Please try to solve this. I will give you 2 minutes of time, and it's a very good question also. Now see, students, I have given you enough time here. The question here is, a culvert is designed for a flood frequency of 100 years and a useful life of 20 years. The risk involved in the design. Okay. Now see, students, first of all, whenever these kind of questions are given, first you should know the probability of success is given by the formula P is nothing but 1 upon return period, P. Okay. And let me tell you what is Q, sir. Q is equal to 1 minus P. If they ask you the probability of occurring, the probability of success in n consecutive years, if they give you, then the answer is P power n. Okay. If they tell you the probability of not occurring, then it is equal to Q power n. But in this beautiful question, they have asked what is the risk involved. Sir, for this, if they give you this word, what sir? What is risk involved in hydraulic structures means, sir, if the probability of 1%, at least once it will fail, that also we have to consider this as risk involved, because according to the safety point of view, it should never fail, right? So that is the reason the probability of occurring at least once, the probability of occurring, the probability of occurring the probability of occurring at least once is given as the directly as the risk involved. So my dear students, whenever they use the word risk involved, or you say hydraulic risk, or whatever, hydrological risk or hydraulic risk, then the probability of occurring at least once will be taken as the hydraulic risk. So here the probability P is equal to what, sir? 1 upon T. Now my dear students, in the problem, they have mentioned return period is how much, sir? They have mentioned return period is equal to how much? Return period is equal to 100 years. They have mentioned return period is equal to how much, sir? 100 years. Am I correct or wrong? So here the probability of this thing will be equal to P upon 1 by 100, which is equal to 0.01. Yes or no? So here if you see the probability is how much, sir? It is equal to 0.01. Now what is the hydraulic risk occurrence? The probability of occurring at least once will be your answer. If the probability of occurring at least once, how do you write the probability of occurring at least once? Total probability is 1. This can be written as the probability of occurring at total probability 1 minus the probability of not occurring will give you the probability of occurring at least once. So the formula for the probability of not occurring, the probability of occurring at least once is 1 minus q power n. Yes or no? So here it P is equal to 0.01. Q will be equal to what, sir? 1 minus P, that is 1 minus 0.01. So it will be equal to 0.09. But in how many consecutive years they have given? The risk involved in the design of the curvette in the life of 20 years. So please understand here, hydraulic risk means you have to calculate the probability of occurring at least once. If the once also it occurred, it is a risk. So here the formula is 1 minus q power n. So 1 minus of 0.99 power 20. So you will get an answer of 0.182. And if they give you the answer in percentile, this should be equal to 18.2 percentile. This will be equal to how much, sir? 18.2 percentile. So my dear students, let me tell you here one important thing. What is the important thing I would like to tell you here is, whenever they used the word hydraulic risk or risk involved, the probability of occurring at least once will be the hydraulic risk. So the probability of occurring at least once is given by the formula, because the probability of occurring plus not occurring should be equal to 1. So 1 minus of not occurring will give you the probability of occurring at least once. So 1 minus q power n, and if you plug in that values, you will get a value of 18.2 percentile. So please read this question also, students. I'll give you 2 minutes of time. Students, first read the question properly, Amma. There. Whatever the given data, try to understand it. Okay, I've given you enough time. Now see students, what is the question here? The infiltration capacity of a soil follows F is equal to C1 plus C2 e power minus KT. Okay. And during an experiment, the initial infiltration is 200. After a long time, the infiltration falls to 25 mm per hour. The infiltration capacity after 1 hour is 90 mm per hour. The value of the decay rate constant is. So they have given the equation of infiltration is what, sir? F is equal to C1 plus C2 e power minus KT. Okay, now see students, actually if you see the infiltration equation, this is given by this formula. Fc plus F naught minus Fc into e power minus KT. So in this formula, C1 represents the final constant and C2 represents the difference between them. Okay, sir. The final constant of infiltration is how much, sir? 25 mm per hour. So here in the problem they have given Fc is equal to how much, students? What is the value of Fc? Can you tell me? The value of Fc is given in the problem as 25 mm per hour. How much, sir? 25 mm per hour. Okay. Similarly, they have given, this is final. If they given, sir, people confused, sir. This is final. And this is what, students? This is the initial ratio of infiltration. So what is this value they have given? 200 mm per hour. Okay. And the duration is given as how much? Can you tell me, my dear students, what is the duration? Duration is nothing but 1 hour. Duration is how much, sir? Duration is nothing but 1 hour. So if you see here, students, they have given F is equal to what, sir? C1 plus C2 e power minus K into T, right? Now what is the C1, sir, from here? C1, if you see, C1 is nothing but Fc. So F can be written as 25 plus, what is C2? C2 is nothing but F naught minus Fc. So 200 minus 25. This value is equal to how much, students? This value is nothing but 175 mm per hour. Okay. So this is C naught value and this is, sorry, C1 and C2. So this is 175 e power minus K T. Now after 1 hour, the total infiltration is given in the problem as how much, sir? 90 mm per hour. But after 1 hour, what is the total infiltration, sir? 90 mm per hour. So time is also given as 1 hour and the total infiltration is given as how much, sir? 90 mm per hour. So my dear students, if I plug in the values, okay, 0 to 1 means directly we can do, sir, because other one is 0. Are you getting me what I am trying to say? So here it is 25 plus 175 into e power minus K into 1 is equal to 90. Okay. Now see students, if you see e power minus K is equal to 90 minus 25 upon 175. So if you see K is equal to minus of ln of 65 upon 175. So if you see that, you will get a value of K is equal to minus 0.99 per hour. And remember what is K? This is the final answer, sir. What is the K? We call it as K, we call it as decay constant. What is K we have, sir? Decay constant. Okay, please write down the students. Okay. Okay. Please write down this question, students. I'll give you 2 minutes of time. Okay, students, see here. Let me tell you what is the question here, sir. A taller unit hydrograph 1 centimeter excess, triangular in shape 144 R, base width and discharge 23 meter cube per second. What is the area of the catchment? Sir, see, suppose, first of all, you should know this sum, this problem. What is the question here is, if you considered what is runoff volume, if they give you runoff volume, what, sir? If they give you runoff volume, okay, runoff volume is nothing but what, sir? Runoff volume is nothing but area, what we call this as catchment area into runoff depth. What, sir? Runoff depth. Okay. Now see, students, if you see a hydrograph, it is a graph drawn between discharge and time. What, sir? Suppose I am drawing for example, okay. A hydrograph is a graph drawn between discharge and time. Okay. So my dear students, if I find the area of the hydrograph, if I find the area of hydrograph, that will be equal to, what will be the area of the hydrograph, sir? That area of the hydrograph will be equal to what, sir? This will be equal to runoff volume. The area of the hydrograph will be equal to how much? This will be equal to runoff volume. Agree or not, sir? Area of the hydrograph is equal to what, sir? Runoff volume. Okay. Now see, students, there they have given, it is a triangular hydrograph. What, sir? It's a, they have given that it is a triangular hydrograph. Okay. Okay, sir. Now see, students, they have given What is the discharge, sir? Discharge is 23 meter cube per second and 144. So if you see the discharge here, discharge is how much? 23 meter cube per second, peak discharge. And the time duration is how much, sir? 24 hours. 24 or 144, sir? I think 144, sorry. Time duration is how much? You can say 144 hours. So how to find out this area, sir? How to find out this area? Area is nothing but half into 23 into 144. 144 is what? 144 is the number of hours. So this is meter cube per second. So into 60 into 60. This will be equal to what, sir? Runoff volume. Okay. Now, they have told in the problem one thing very clearly. It is a unit hydrograph. Am I correct or wrong, sir? It is a unit hydrograph. So, for unit hydrograph, when the word unit hydrograph comes, this will be always 1 centimeter. What, sir? What will be the value? That value will be always equal to 1 centimeter. So, in meters, if you see, this will be 0.01 meter. Okay. Now, my dear students, I am equating the equation. Runoff volume is equal to what, sir? Runoff volume is equal to catchment area. Runoff volume is equal to what, students? Catchment area multiplied by depth. What, sir? Runoff volume is equal to catchment area upon multiplied by depth. So what is runoff volume here? It is, we have half into 23 into 144 into 60 into 60. Yes or no? Is equal to area, catchment area into depth is how much, sir? 0.01. Yes or no? So if you solve this, you will get an answer area as 596.16 into 10 power 6 meter square. But 10 power minus 6 meter square can be converted into kilometer. So you will get the final answer because they asked the answer in kilometer square. So the final catchment area here is 596.16 kilometer square. So the biggest thing here you should remember is, the key point is area of hydrograph. Area of hydrograph is equal to what, sir? Runoff volume. This is a very, very important point where you can solve some gate questions. And remember, runoff volume is equal to area into depth. And for always remember, for unit hydrograph, what is the depth, sir? The depth is equal to 1 centimeter. I hope you are clear. So please write down this. Okay, I hope you have written that. Next, read the next question, sir. This is also another important question. I'll give you 2 minutes of time. Try to solve this question. I hope you have done the problem, students. Now see, in this problem, if you read the question, okay, a triangular direct runoff hydrograph due to a storm has a time base of 90 hours. The peak flow is 60 meter cube per second at 20 hours. From the start of the storm, the area of the catchment is how much, sir? 300 kilometer square. The rainfall excess of the storm. So here see, it is also a triangular and peak is 60. Duration is how much, sir? 20 hours. Occurs at time base is 90 hours. And the area of the catchment is 300 kilometer square. Now let me tell you here. If you see the graph here, okay, it is discharge versus time. Sir, my dear students, here they have told that it is reaching the peak value in first 20 hours only. Okay. And next overall time is how much, sir? Overall duration is how much? 90 hours. Okay, they have given. And what is the flow? Peak flow is 60 meter cube per second. 60 meter cube per second. Now what they have given you, see students, they have given you the catchment area. What, sir? They have given you the catchment area is how much? The catchment area is given as how much? Okay. Here the catchment area is given as 300 kilometers square. The catchment area is given as how much, sir? 300 kilometers square. Now see students, if you consider here runoff volume is equal to what, sir? Catchment area into what, sir? Into runoff depth. Catchment area into what, sir? Runoff depth. Yes or no? Now my dear students, if I talk about runoff depth, that is equal to runoff volume upon catchment area. What is runoff volume? I told you how to calculate runoff volume, sir. Runoff volume is nothing but area of hydrograph. Yes or no? So here what is the area? Peak height is how much? Height is 60 meter cube per second. So runoff depth is equal to half into 60 into 90 into 60 into 60. This indicates what, sir? Into seconds conversion. Hours into seconds. Okay. Divided by catchment area. What is the catchment area, sir? What is the catchment area? They have given as 300 kilometer per square. But see, whatever the runoff volume you get is what, sir? It is meter cube per second. And we have converted hours into seconds. So it will be in meter cube. So we have to convert this 300 kilometer square into meters. 300 into 10 power 6. Okay. Now can anyone tell me what is the answer you got, sir? If you solve this, you will get 0.0324 meter. What, sir? 0.0324 meter. Am I clear, my dear students? So if you solve this here, 0.0324, if you solve this into centimeters, this value will be equal to 3.24 centimeters. Are you clear, sir? So what is the key takeaway from this is area of hydrograph is runoff volume. Runoff volume is area into runoff depth. And runoff depth, so here if you see the options here, they have also asked you, see, they have asked runoff depth in what, sir? They have asked you the runoff depth. If you see here, The runoff depth is in centimeter. So you got 0.0324 meter, right? So if you convert into centimeter, it is 3.24 centimeter. So the option here is B. Agree? So please write down this, students. I hope you are clear with this problem. Okay. This is one of the good questions, sir. Today is try to solve this question. I'll give you 2 minutes of time. Try to solve this question, students. Okay, students. Now see, students, read the question here. Two reservoirs are connected through a homogeneous and an isotopic aquifer having hydraulic conductivity 25 meter per day, and the effective porosity is 0.3. Groundwater is flowing in the aquifer. If the water in reservoir is contaminated, then the time required to reach the reservoir too. So I'll give you just 2 minutes of time. Just think of it, sir. Okay. I have given you enough time, sir. Now see. Now see, students. There is a law called, according to Darcy's law. I hope everyone is following, sir. Okay, according to Darcy's law, according to Darcy's law, according to Darcy's law, velocity is proportional to hydraulic gradient. According to Darcy's law, velocity is proportional to what, sir? Velocity is proportional to hydraulic gradient. Or you can say V is proportional to I. This is what Darcy's law states. Now some X is proportional to Y, you write X is equal to some constant to Y, right? So you will write this equation as velocity is equal to I into K. Okay. Now my dear students, what is K? K is nothing but the coefficient of permeability. What is K, sir? K is nothing but the coefficient of permeability. What is K, sir? K is nothing but the coefficient of permeability. What is V? V is equal to what, sir? IK. Now here see students, what do you mean by I? I is nothing but the hydraulic gradient. What sir? I is nothing but the hydraulic gradient. So what do you mean by hydraulic gradient here? What do you mean by hydraulic gradient? So here you should understand that I is equal to what sir? Delta H upon L. What is mean by this? I is equal to delta H upon L. Agree? So delta H is nothing but what sir? Loss of head. Okay, so here what will be the loss of head? 30 meter and 10 meter, if you see here. Now see students, let us solve this question now after that concept. Okay, in the problem the water table is at a height of 30 meter and here it is a height of 10 meter. Okay, see students. Now what is loss of head? Let me tell you. What is I sir? Hydraulic gradient I told you delta H by L. So I is equal to 30 meter minus 10 meter upon 2 kilometer. This is kilometer and this is what sir? Meter. So if we convert this kilometer into meter, this will be 20 meter upon 2000. So 1 by 100. So it will be 0.01. Am I correct or wrong sir? Please check it. It will be equal to 0.01. Now some people will ask me here, hydraulic conductivity or permeability both are same sir. Okay. Hydraulic conductivity or permeability both are same. Here see students, hydraulic conductivity is given as hydraulic conductivity, or you can say hydraulic conductivity, or you can say what sir? Permeability. Hydraulic conductivity or permeability, K is equal to how much sir? 25 meter per day. What is this sir? 25 meter per day hydraulic conductivity. Now you know velocity is equal to what? I into K. Velocity is equal to what sir? I into K. So this will be taken as 0.01 I and K is 25. So velocity is equal to how much sir? 0.25 meter per day. Velocity is equal to how much? 0.25 meter per day. Now see students, again I will tell you seepage velocity. Seepage velocity. Actually there was a derivation not required sir. You might be learning in when your classes are going on. Seepage velocity Vs is equal to V by N. Okay. Now what is the velocity you got? 0.25 and the porosity is given as how much sir? 0.3. So Vs is equal to 0.25 upon 0.3. So this is equal to 0.833 meter per day. Now see students, here I would like to tell you one important thing. What is the important thing here is seepage velocity is equal to V by N. It is the like concept I am trying to say sir. Okay. Seepage velocity is always greater than the actual velocity because the porosity range is between 0 and less than 1. What is because sir? The porosity range is between 0 and less than 1. So once the denominator is less than 1, seepage velocity is always greater than 1. Agree or not? So you got seepage velocity is how much sir? 0.833. Now what he is asking? What he is asking, water reservoir is contaminated, then the time to taken by the contaminated water too. So you know seepage velocity or velocity is equal to distance upon time. Distance upon time. So what is the seepage velocity you got sir? What is the seepage velocity you got? You got seepage velocity and calculation is 0.833 meter per day. And distance is nothing but what my dear students? It is nothing but the Distance here is what, sir? Distance is nothing but the length of travel, that is 2000 meter, right? So if I plug in these values, 0.833 meter per day, right? Meter per day, because I will write the units so that you will not confuse. Distance is 2000 meter divided by time. So time is equal to 2000 divided by 0.833. Yes or no, my dear students? So time is equal to if you solve, can anyone tell me what is the answer you got? You will get an answer of 2400 days. Okay. So this is how you have to solve the problems related to the CPACE. Okay, please write down this all equation, students. Okay, I hope you have written this. After this, we have calculated the seepage velocity, and after that, we have calculated the time. Okay. Now, this is also a very good question, students. Try to solve this question. I will give you 2 minutes of time. Please try to solve this. Okay, please try to solve that question, students. Okay. Now see, students, here the question is, in a homogeneous unconfined aquifer, what is the area, sir? What is the area? 3 kilometer square. Okay. Area is given as how much, students? 3 kilometer square. Now the water table has an elevation of how much, sir? If I consider the water table is elevation is 102 meter. After natural recharge, means the water is coming inside. The of recharge of volume, how much, sir? Volume is how much? Volume is equal to 0.9 million meter cube. How much, sir? It is 0.9 million meter cube. So you can write it as 0.9 into 10 power 6 meter cube. Yes or no? So you can write it as 0.9 into 10 power 6 meter cube. Am I clear or not, my dear students? Okay. Now this, as the water is coming inside, this has been raised to 103.2 meter. From 102 meters, it has been raised to how much, sir? 103 meter. And the volume is how much, sir? 0.9. After this recharge, the groundwater pumping took place and the water table drops to 101.2 meter. From 103.2 it is falling to 101. The volume of groundwater pumped after the natural recharge. Sir, see. First what, sir? The water table has been reached and a natural recharge. Now, see, initially volume is given as how much? 0.9 million meter cube. Then it is what, sir? 0.9 into 10 power 6 meter cube. And here what is the area they have given, sir? Area is given as 3 kilometer square. Area is given as how much, sir? 3 kilometer square. So here if I take area is 3 kilometer square, then it is equal to 3 into 10 power 6 meter square. Then it is equal to how much, sir? 3 into 10 power 6 meter square. Now see, volume is considered as what, sir? Volume is equal to area into depth, and if they give you the, you have to find out the specific yield here, how much yielding has been done. Now volume is how much, sir? 0.9 into 10 power 6 is equal to 3 into 10 power 6 into depth. Depth is how much, sir? From 102 it has raised to 103.2. So 103.2 minus 102 into specific yield you will get. Okay. Now my dear students, if I see here 10 power 6 cancel, 3 into, you can write here 0.9 is equal to 3 into 1.2 into specific yield if you do the calculations. So specific yield is equal to 0.9 divided by 3.6, which is the value which is equal to 0.25. What is the value of specific yield, sir? The value of the specific yield is how much? It is equal to 0.25. Am I correct or wrong, sir? So here see students, now from 103.2 it has dropped to how much? It has dropped to 101.2. What is the volume of groundwater pumped? So volume of groundwater pumped, what, sir? Volume of the groundwater pumped is equal to area. Am I correct or wrong, sir? What is the area they have given? Area is always fixed. So 3 into 10 power 6 into, from 103.2 it is falling to 101.2. So it is almost, the difference is 2 meter. Yes or no, sir? Into specific yield is how much, which is constant, which is 0.25. Okay. So if I do here 3 into 2, 6 into 0.25, 1.5, 1.5 into 10 power 6. If they ask you million meter cube, 1.5 into million meter cube. This is the final answer. So my dear students, if they ask you, they have asked, see here, this is very important, sir. So they have asked you in the question, what is the natural recharge expressed in million meter cube? So it will be how much, sir? 1.5 value. What is the value? Here we have, what is the value, sir? This value is equal to how much? 1.5 million meter cube per cube. So here it is 1.5 million. Okay. So any doubts in this question? You can ask me, students. Okay. Okay, next question. Okay, Muskingum method is used in, direct question amma, it is used in hydraulic channel routing, but here you should know the coefficients. This was one of the gate question also. The summation of the coefficients should be equal to 1 in the Muskingum's coefficient. Okay, C0 plus C1 plus C2 should be equal to 1. And remember, the Muskingum method is used in where, sir? It is used in the hydraulic channel routing. This question you try to read, sir. A reservoir with a level storage of 300 million meter cube irrigate 4,000 hectares of crop with 2 fillings. This word, so many people will do mistake. If the base period of the crop is 120 days, the duty of the crop is. So please solve this question and I will give you 2 minutes of time. Okay. If you have any queries, you can ask me, students. Sir, try to read the question. A reservoir with a live storage of 300 million cubic meter cube irrigates 4,000 hectares of crop with the 2 fillings of the reservoir. If the base period of the crop is 120 days, then the duty of the crop in a hectare per cubic rounded off to integer will be will be. Try to understand the question carefully, students. It's an easy question. Try to understand it. Okay. Sir, okay, I have given you enough time, Amma. Here, see, students, let me small correction in the question actually. Here it is 40,000 hectares, okay, not 4,000. I am writing here it is 40,000, okay. Now, see, students. Sir, see, read the question here. A reservoir with a live storage of 300 million cubic meter irrigate an area of 4,000 hectares. 1 hectare is 10 power 4 meter square with the 2 fillings of the reservoir. If the base period is 120 days, the duty of the crop is. Sir, he is asking, first of all, you should know this. Duty is equal to 8.64 B upon delta. Okay, sir. Duty will be always in hectare per cubic. Delta will be in meters. Base period will be in days. Okay, this is the basic formula. Now see, student, here volume is given as how much, sir? 300 million meter cube. So here you can write it as 300 into 10 power 6. But let me tell you, in the problem, what they have done, sir? In the problem, they have done 2 openings. Are you following, sir? In the problem, they have given you 2 openings. This has a lot of significance. As it is having 2 openings, we are multiplying with 2. Okay, so my dear students, this will be equal to how much, sir? 600 into 10 power 6 meter cube. Okay. Now, my dear students, what they have given the hectares, sir? Area is given as how much? What is the area they have given, sir? The area is given as 40,000 hectares. The area is given as how much, sir? 40,000 hectares. Agree? Now, they have given you volume and they have given you area. Now, see, students, if they ask you depth, if they are asking you depth, depth is nothing but what, sir? Volume upon area. What is depth, sir? Volume upon area. So, area is how much, sir? Volume is how much? 600 into 10 power 6 upon 40,000. And remember, my dear students, They have given in the question, still if they have not given also, you should remember. 1 hectare is how much, sir? 1 hectare is nothing but 10 power 4 meter square. Agree? So if I do 10 power 4 here, so 10 power 4 cancel. So this value will be equal to how much, sir? 1.5 meter. So 1.5 meter is nothing but what? Delta. What is 1.5 meter here? Delta. Base period is 120 days, right? So duty is equal to what, sir? Are you following, students? What is duty? Duty is equal to 8.64 B by delta. As I told you, what is the base period there? I think 120 days, right? Let me check it. 120 days, right? 120 days, very good. And here we have delta is how much? 1.5. So 80 into 8.6. So it will be around 3.2, 480, 48, 88, 640, 48, 692.1 hectare per cubic. 3.2 or 692.2 hectare per cubic. Any doubts in this, students? So see, students, whenever you are preparing the hydrology irrigation concepts, okay, first give importance to the Thiessen polygon method. First give the importance to the Thiessen polygon method. Next, phi index, Horton's equation, and also give importance to hydrograph, unit hydrograph and a hydrograph. Crop period, base period, delta period, irrigation in this. And also you try to give the things also for confined and unconfined aquifer. Okay. If you can concentrate on these topics, and you can ask me after the GATE exam also, sir. Most of the questions from hydrology irrigation will be coming from this topic only. Okay. I hope you are clear with this concept. So have you written this, students? So please write down this once again. Please write down this solution, okay, before moving on to the. Okay. I hope you have written this question, students. Now see, students, what we do at IMS GATE Academy. So my dear students, you might have done all the preparation and you want to practice yourself. So it is the time to test yourself, and it should be a time bounded test, and you should have a practice of all the mock tests, means all the kind of questions like MSQs, MCQs, NATQ, and also you should be accustomed to the virtual calculator. So we at IMS GATE Academy are introducing the test series plus combination. And let me tell you, not only test series, sir, the previous year GATE questions also plays a very vital role, because 20 to 30% of the concepts will be taken from the previous year questions. So we are providing the test series plus, which includes 12 test series, which includes of MCQs, MSQ and also NAT. Along with this, we are providing the GQB 33 plus years of GATE questions with the video recorded solutions for some of the important questions. In addition to this, my dear students, we are providing the doubt solving portal. Suppose if a doubt has been posted, you can ask your doubts still in the AMTS, All India mock test also. If you are facing any challenges, you can paste in the doubt portal. So whatever the post GATE guidance required for you after the GATE exam, like for your GATE score, what should be the, which college you have to apply, all these details will be given in the test series plus. Now my dear students, what we also have a Telegram group where daily quizzes will be happening. You can join this Telegram group. Link is given in the description, and through this link, my dear students, you can get daily quizzes, PSU job notifications, what are the government jobs, or you can say what are the opportunities through the GATE exam. And related to the GATE exam, as we are nearing to the GATE exam, any updates, any official updates, we also post in the YouTube. Still we have the Telegram group where you can experience the feel of the GATE questions also. So my dear students, if you have any questions regarding the queries, you can post in the comment box, okay. So I hope in this video I have given you the experience of the hydrology irrigation questions. And one thing I would like to conclude here, students, if you are preparing for the GATE exam, give your 100% in these 2 months, because these 2 months will change your career. And definitely follow this simple rule: efforts are proportional to your success. If you do more and more efforts, if you do these 2 months, maximum 10 hours to 8 to 10 hours of your consistent study, then your 30 years graph will be good. So if you, so and remember always, if you are a student who want to get into IIT or ISC, then GATE is a platform. Through GATE exam, you can easily get into the IITs or ISC. Even in the PSU job notification, especially for civil engineering, we have lot of notifications. So please get into, please give your 100% and try to achieve your success. Thank you and all the best.